Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on the series Deep Learning. In this Deep Learning, we will be covering the convolutional neural network using this Anaconda 3. Now, before starting, let us have some brief discussion about what is this Anaconda 3 and how we will go for this Deep Learning. Especially we will be using this convolutional neural network, and as you know, this convolutional neural network, it is a feed forward neural network, and that is generally used to analyze visual images by processing data with grid like topology. It is also known as the net or the convolution net, and a convolutional net neural network, it is used to detect and classify object in an image. Okay, this is the main thing you do it here. If you see the diagram from the figure, you can understand. Here what is the image that is converted to some pixel that is provided as the input. Suppose you provide here it is a cat, okay, and here it is given to the input layer, and we have a number of hidden layers and one output layer, and there are different things. One is the dog, one is the bird, one is the cat. So finally it will show you that this object what you are showing it here, it is a cat at the bottom. Okay, so different here, there different colors are there. One is the purple color, one is the black color, one is the little bottle green color. So this is thing it is done. So imagine there is an image of a cat. You see this is a cat, and you want to identify whether it is really a cat or some other animals or object. And the first thing we need to do is to feed the pixel to the image in the form of an array. So this entire image is converted to an array of input that is given to the input layer. So this is the input layer of the neural networks, and this is I told you that multi-layer neural network, and it is purely used to classify things. And the hidden layers carry out feature extraction by performing different calculations and manipulations. You see these are the some color, brown color it is coming. So it is used only for extracting the features or feature extraction, right? And this is used for calculation and manipulations. And there are multiple hidden layers like the convolution layer, the Reu, the rectangular linear something like that unit, and the pooling layer. So these are all the hidden layers, and that perform feature extraction from the image. Finally there is a fully connected layer. So you find it here, some fully connected layer that identifies the object, what is the category, which category belongs, it is done. Say you take an example here. Suppose this is an image, a real image, it is some human face or like that is showing. So here some data is there, some circles, some let it represent eyes, this represent nose, this represent the mouth. So these things are represented by the pixels, which are represented by the black square. Can you see 1 unit is square? So this is 1, this is 1, so this is the also given. So these things are represented like this. Now in this grid pixel, whatever you see it here, where data is there, this black square is there, that I convert to binary number 1, remaining all 0. That means second row, second column it is 1, second row last but one column it is 1, like that where data is there I converted. So this is converted in the matrix form. Is it clear? Then after that what do you do? Then you go for the convolutional layers in the convolutional layer network. We have the convolutional layer, the Reu layer, and the pooling layer, and the fully connected layer. What is the job of this convolutional layer? As you know, we are going to go for the convolution, and there is a concept of convolution. Suppose one image is there, or whatever the signal is there, and one impulse response is there. So we can go for the convolution. Suppose xn is the image and hn is the impulse response to that one. So xn convoluted to hn, it is like xk into h k minus n, like that, okay, or n minus k. So this is the mathematical formula. Using this we can go for, that means that impulse response is convoluted on each and every pixel there, and it is shifted to the right, so left to right. Get it now? So it can be it can be in the form of a filter. So usually it can be 3 by 3 or 5 by 5, like that. So these things we take it on the entire image and operate from left to right, and from left side top to right side bottom screen, right? Now consider the following. Suppose we take a 5 by 5 image whose pixel values are either 0 or 1, what I have given there it is given, and there is also a filter matrix, what we are telling the response. with dimensions of 3 by 3. Slide the filter matrix over. Now what you are doing, slide the filter, just what in the shifting, slide the filter matrix over the image and compute the dot product to get the convolutional feature matrix. Okay, so this is the thing it is done using this you got it. Now the entire image is like this. This is the entire image. Now you take a 3 by 3 like this. Now you operate it here and go for the dot product, then shift 1, then go for the dot product, then shifted 1, this 3 dot product here, like that, then go to the next line. Entire thing is carried out from left to right and from top left to right bottom, right. That means it is here gone here in this my direction also. Clear? Now then what you do, then you go for the Reu layer. So it stands the rectified linear unit, rectified linear unit, and once the feature map are extracted, the next step is to move the Reu layer. The Reu performs an element wise operations, and it here see, instead of going for these things, the negative is converted to 0 and positive as it is. That is the part we go to the, so a function we put it there, so maximum so 0 and z like that, and you put it here and it is rz. So suppose this is a body, you can see, suppose this is the input image, it is the color image RGB there. So when you pass through this when you convert to the feature maps is converted to the pixel value, so then become the feature map here. Okay, so and this feature map when is passed through this Reu, that means the negative value becomes 0 and all the positive value as it is converted to rectified feature map like this. Okay, then in the pooling layer what you do, and pooling is down sampling operations. Say for example we have a feature map like this. In the rectified feature map what we try to do, so we this is, you can see 4 by 4 is there, so 4 by 4, then maximum pooling with 2 by 2 matrix and slide. So what you do, so this is the these things I go on sliding. If you see this one, this 4, so out of this what is the maximum one, maximum is 6. That means when I downscale to this as 4 by 4 to 2 by 2, so out of this what is the maximum, 1 4 2 6 is maximum, so 6 is represented in this column. That means this 2 by 2 entire color, this is represented by 6. Then that bottle green color, if you see here 2 7 5 and 8, the maximum is 8, so it is represented 8 here. So 3 4 1 and 2, maximum is 4, so 4 is represented blue color, and 0 7 1 3 maximum is 7, so that is represented by the pink color. So this is the things what you do using the when you have taken the maximum value, then remaining by default it is there. Got it now in the pooling layer. So if you see the after passing through that one, whatever the things images, you can see it here, right. So now what we do it here, so this is our input image which is converted to in the binary form, then it is passed through this convolution layer, the Reu and everything there, then we are going for the pooling, that is down scaling, we are doing it here, and finally it is coming in the form of 6847. What you got it there, if you see the 6847, same 6847 I am the input I am putting in the pooled picture map. So this is flattened, that means first 6 then 8, it is, you see it is a n by 1 column or 4 by 1 column, it is just like vector, it is in the vector form, right, because I told you that the in our neural network the input we take it as a vector, we say x is the input vector, so this is 6, then is 8, then is 4, then is 7, so it is taken in the form of a vector. So that is the input it is given to here, you get it now. Now using all things we will be able to you get it now, whatever the things you are getting, now you can see it here, then it is passed to a fully connected layer, we all are connected to each other. After passing that, the entire things, so suppose the input was cat and all these things you pass through all the things, then finally you are getting, so it is a cat. Is it clear? So this is what exactly we are going to do in our neural network, right. So how exactly CNN recognizes a cat? The pixels from the image are fed to the convolutional layer that perform the convolution operations, and it results in a convolution map, and the convolved map is applied to the Reu where it converts the negative to 0 and positive as it is. The image is processed with a multiple convolution Reu layers for location of the features and different pooling layers, so this is we have already explained, and finally you find, so these are the things, finally you come here. So we will be implementing using this our Anaconda 3. for the data we can use this, what is the website I have given it here, https:// and www.cs toronto.edu. so this the two type of data is there. One is the 10 and CIFAR 10 and CIFAR 100. so both the data we can download, and the coding part will do it here. Now next part is there. Up to this it is okay, you have done, and some output we got it here, that is different thing that I will be showing practically, don't worry at this moment. Now how to implement using this anaconda? See, for implementing this anaconda, now again switch to my thing here. If you see here, I just type it here Jupyter Notebook. If you type Jupyter Notebook, just to type JUPI Jupyter Notebook, you can see Jupyter Notebook is a Resampling. Okay, before you go to the Jupyter Notebook, okay, you go to the Jupyter Notebook, there is no issue on that one. So before that, okay, I show you in the Jupyter Notebook what is there, nothing to worry. So you see here, this is the Jupyter Notebook, where it looks like this. The first time you open, it looks like this. When it is installed Jupyter Notebook, I actually installed the D drive, but here you see the new. Initially there will be only Python 3 IPY kernel. Now this R is not there initially. So until you install that one, you can work on that one. How to install that one, that I am telling to you. Okay, first you note down all the things, pausing this video, then once you install all the things, then you can work on that one. Fine. So now let us go for that one. So you go to the start. Where is the start here? You see it is the start here. Then you go to the Anaconda 64-bit. Okay, because my system 64-bit, and you click it here. While you are clicking it here, can you see it here? Here you will having the Anaconda power prompt cell, PowerShell prompt, and also Anaconda prompt. You go to the Anaconda prompt. Once you click the Anaconda prompt there, so some prompt it will appear in front of you. Then because I installed in D drive, so just type D : and enter, right? Then go for change the directory CD. All are lowercase, nothing to worry, because by typing it is coming uppercase, but all lowercase. CD change directory / Anaconda 3. So then you will be there in this Anaconda folder. Then here what you need to do, you need to install. All are lowercase, remember, there is nothing to worry, it is appearing whatever things. So conda space install, again I am repeating, conda space install space -c space r hyphen kernel. Just enter it there. Then it will try downloading that one. So then what you do, then you have to, then it will, until it shows proceed yes or no, you stop there, don't do anything. So once it shows proceed yes or no, you type proceed yes and press enter, then it will install. Okay, so once it is installed, then on completion just to restart, and you will find that a new that R program also appears in front of you, right? So when you go to the new and click it here, R program appears in front of you. When R program is just to click it, that R, and after that what happens, some interface it will come, because all the coding I have written, but by default it will not come like this. So only a blank empty things it will come like this, right? Then you by default some home page will be there, then you name it so convolutional neural network. Just double click and give a name to that one and enter. So now we are going to work on this convolutional neural network, right? Now to unzip that one, we are using the function def unpickle the file. Okay, so then what you do, import pickle. Then what I am doing with open, so with this open function, what I are going to open the file and RB. What is the, this is only reading the binary form, read. So if it is R plus, then read and write, it is there, or WB only write the binary file. So we will be using the read the binary file as FO. A new file is created. So now this peak.load FO comma encoding, which is equal to Latin 1, the default, nothing to worry about all things. This will save it as the dictionary. So you are creating a dictionary, a return dictionary. Now what is the, this is only to open the file. We are using this function, and using this you just click it here and run shift enter or control enter, it is running. Up to this there is no problem. Then what you need to do, we need to load and pre-process and visualize the CIFAR 10 and CIFAR 100. Then what is the thing we load, data underscore batch underscore 1. So this is the things we are going to load, right? So now how to do that one? So what is the things you are telling? You are going to open file. What is that file? File is equal to what we downloaded CIFIR -10 batches -py. So that with the name there will be a number of things like data underscore batch number 1, batch number 2, batch number 5, up to like that. So I am going to access the data underscore batch -1. So then this one, which is you have to unpickle the file, right? Whatever the files you have taken, unpickle. Now it has unzipped. Now if you want to print what is the type of this file, you got it now. After unpickle, after the unzipping all things, it will be stored in this data underscore batch underscore 1, right? So because there are so many files, just that's why to identify I have given the batch underscore 1. Now you print the type of these things, it is saying it is a dictionary type. So whatever things you know, what are the array, what is the dictionary, and all things you know, vector. So then then if I want to print the data of this and dot keys, what are the keys method using these things? So we have the batch underscore level 1, then labels, then data and file names, all the things are there, the different keys there, right? And for item in data underscore batch number dot 1, this print item type. So if you see, you try to print out the item and what is the type. So batch underscore label, it is a string, and labels, it is also a list, it is coming, and data like that, or file name, everything it is coming here, right? Now if you want to what are the labels you want to print, so this is all the Python commands. I hope you are acquainted with all these things. Otherwise you will have a separate videos to tell the fundamentals of Python. I think in the initial classes already covered, so you can go through that one, or if you need it, please just write a comment so that all the details we can discuss in details. So print while you are going for the labels. So because I am putting on double quotation, it is just taken as a string. Then set data underscore batch labels. So then what you will do, so with this it is dividing into different number of labels, like 0 to 9, 10 number of labels it is, because I am having 10 number of attributes there, right? So 10 number of columns it is creating. Now now what I am going to do, I am creating data underscore batch. I want to create this data and I put it as a x underscore train. So if you run this x underscore train, so the entire data is appearing what is that, right? Now if you want to know what is the number of rows and columns, so x underscore train dot shape method you are using, so it is coming 10,000 by 3072. Why it is 3072? Actually it will be 1024, but there will be 3 number of colors RGB, so 3 into 1024, that is coming 3072, right? That is the things, because we will be using the color images you are using, because I already told you that is the reason you have taken it like this, okay? Now, and for the image label names, we load the file batches.meta, okay? How to create the image label name? So meta underscore file, which is equal to this one. Then if you go for the meta underscore data, unpickle this meta file, this one, okay? Then it is okay. Up to this it is running, just you shift and enter, then print type of meta details and print meta, all these things it will showing you this is a dictionary, and the dictionary keys are these are the keys, numerical case per batch, the label name and numerical, all visualization it is coming. Then what you do, print label names of this meta underscore dictionary. It is saying it is coming airplane, automobiles, but these are the different category of the images. It belongs to that one: bird, cat, deer, dog, frog, horse, sheep and truck. These are things it is there. So you want to reshape all that thing. So image is equal to data underscore batch number underscore data, you are putting 0, and I told you that the images we have taken 32 by 32. If you multiply 32 it will be coming around 1024, okay? And you are taking 3 into 1024, it is 3072, that is the reason it has come. Then if you want to print the image dot shape, so it will be coming 32 by 32 size, and there are 3 because RGB different colors will be there. Then image is equal to image dot transpose 120. That means what is the data is there initially, I want to make it 32 by 3. For that one I do image dot transpose method, this 120, that I convert into 32 0, okay, sorry 3. Then for reshaping what you do, now you go for the x train, which you go to data underscore batch underscore data. So print shape before reshape, something it is coming. Then reshape the whole image data x underscore train, that is x underscore train dot reshape, then length of this x train, that is 32. So then you print all this, then go for the transpose, everything is done here, and the output by running you can see here. Shape before reshape is this one, shape after reshape it is coming this one. You got it now. So you see initially before reshape it is 3072 as it is whole, but after reshaping it is converted to 32 by 32, 3 groups is converted. Okay, then same thing it is, if you multiply all things it will come also 3072, right? And after reshape it is coming 32, 3, 32, 32, here it is coming 32, 32 by 3. Okay, then for visualizing single image from this CIFAR10 dataset, what you do? So import the matplotlib.pyplot as plt. Then for the label names, label name is equal to meta underscore data, so label underscore names. Then for the first image, image is equal to data underscore batch 1 data, so this is the 0, and this is for the all the things you can do it, the reshape and the transfer of the image and everything you can do it here. And you see if you run this file, it is showing this one, and it is showing the image it is a frog. Okay, because of the resolution it is showing it is like a frog. So visualize, this is for a single image, this is for a single image. If you are going for multiple images, then what you do? Import this matplotlib.pyplot as plt, import numpy as np, because we will be using the concept of array. So image is equal to data underscore batch underscore data, then reshape image is equal to image dot reshape, all the things. Then also okay, then take labels of these images, labels is equal to data underscore batch, that is the labels, and label names of the images. So all things you have done it, right? Then display the random images. For these things what you do? So row column 5 by 5, and image id is equal to np dot random random integer, all things are done. Image is equal to image id, so all things are done. Now if you run this program, this is the matplotlib, so the figure is equal to plt, so matplotlib we will save it as plt, figure is equal to plt dot figure, size 10 by 10, you see it here the size. Then for I in shape, and if you put it there, so all the categories it is showing here. This is deer, this is horse, this is horse, this is bird, this is truck, and this is the horse. So all category it has shown it here. Okay, then if you go for the image classifications of this CIFAR10, then we need to install this TensorFlow. Then you go for the pip exclamatory pip install TensorFlow, import TensorFlow as tf, and from TensorFlow.kara import datasets, all the things, import matplotlib.pip, all things you do it here and run it here. It is running, it takes some time for running, it is fine. Print the label names now from this metadata, airplane, automobile, bird, cat, deer, dog, all the things it is showing. Then we go for this xtrain, ytrain, and here we for the training set we decide all things, training and testing, and data set CIFR load. Then what I am doing, because out of this that one xtrain.shape I am taking only 50,000 data only for training, and 10,000 it is just I am taking 20% of that one, because out of that 1 lakh I think, so only 20% is here, and 90% sorry 80% is here, right? Then what is the xtrain.shape, you get it, and y underscore shape also you get it there is no problem up to this. Then x underscore train, which is equal to this by 2 normalizations, we do it here, xtrain and xtest here. Then the number of classes you do it here using this thing, the number of classes is k, and all this model is equal to model under sequential, you finish all the things. Then what is the hidden layer, model dot add layer dense 1024, activation is equal to ReLU, because we are using a ReLU. What is the rectilinear, so linear unit, I have already told you, model dot add these things, then model dot add these things over the model summary. So once you run this, it will take time, and it has run. Total parameters you are using this one, and trainable parameter is this one, and non-trainable parameter, this is done, right? Then model dot compile, this you compile, it is running fine. Then if you go for the model dot fit, now I am fitting this to a model, so it has run. It will take a lot of time, so I think there are 1563 number of epoch will be there, so one by one it will run, and it will come, and finally it is coming here. It will take a lot of time, and it is running, and around the accuracy it is coming around 96.95, okay, more nearly. Then why then model dot predict xtest, if you provide that 20% xtest data here, so that output will be the y underscore predict, that is saved here. and it is taking some, and y predict all the things it is showing. Okay, all this value it is coming there. So if y predict class you want to put it here, it is also coming like this. Then you go for the prediction, the labeling and all things, and everything is done here. Now the cat, the sheep, aeroplane, frog, everything it has come here up to this. So if you want to plot the accuracy and the epoch and accuracy, all the things, for this you draw this one, plot plt dot plot history dot history accuracy, then value accuracy, then number of epoch and the accuracy and all things will write, and all things you can see it here. And finally the classification report, if you put it there, classification report it is coming. What is the precision, what is the recall, what is the F1 score and support, all this just you press it here and shift enter or control enter, it is coming. Then we can go for the confusion matrix, and we have done this confusion matrix here also, and run it here, it is coming, everything is created. So up to this we have gone for this testing with the CIFR, that is 10. So similarly you can go for the CIFR 100. This is the another data set I have taken out there. So this is the file, is they put it that one, and train underscore data on pickle file. Then what is the type is also is a dictionary. Then print trend, all the keys it is coming as it is previously, because there as it is only there, here it is number is more. So for item train underscore, the file name, class it is a list, and the class here all label name, everything is there, it is coming. Then print fine labels and course labels, everything is coming. Xtrain value it is training here, and extend dot shape it is coming also 50,000 by 3072. From this meta underscore file, you CIFR 100 Python meta, you save it as meta underscore file, and there you unzip, unpickle to find the meta underscore data, right? Up to this it is fine. Then print type of metadata. So I told you that it is a dictionary, in the form of dictionary it is saved. And what is the keys, all the keys it is coming there, right? Then print fine label names. So all the label names, Apple, what are the different categories, all things it is coming. Then print, because it is, that is 10 by 10, it is 100 by 100, remember. So that's why the number of data will be available more. So print course label name, so meta underscore data. So these are the course name, aquatic mammals, fish, flowers, food container there. So xtrain and xtest, you do it here like this as you have done previously. Then you go for the images, and you finally it has taken the image and he identified it is a boy. Similarly to visualize the different layers, you also do it here, and it is able to this is the outdoor scene, plane, and reptile, lizard, this is the man, something like that, everything it is able to do it here. So I hope you got some minimum idea how to work with this convolutional neural network to solve this deep learning related problem. So mainly while you are going for these face recognitions, you are going to even if you can take up a project like that in a classroom, by taking a snap and applying these photos here in this process, you can take the attendance, that is also possible. So thank you for watching this video, and if you like this video, please do share with your friends, and also don't forget to subscribe the channel, it is very important for me. Thank you very much once again. Take care of yourself.